After receiving the equipment, the sequence of wiring is to connect equipment wiring first, then connect wiring of load side. Battery pack load. If our equipment complete the test and need to move away the equipment, when taking the cable, we need to remove the wiring of battery pack first. Remove this end first. After taking it off, let's make sure there is no electricity here. Then we take the cable on equipment side. This is a safe operation. Summary is when start wiring, connect the machine first, then connect the battery wiring. What if it is connected in reverse? If it is connected in reverse, connect to battery first and then to machine. If these two terminals are too close to each other, they may be short-circuited. If people are too close, people are at risk of getting an electric shock. Now let's go through complete operation. Here is a load that simulates a battery. The load side is red cable. Connect red terminal. Represents the whole positive output of battery pack. Then connect the black terminal to the whole negative output of battery pack. Then thinner ones are the sampling lines with red connecting to red. The black connect to black. After the load side is wired, let's take a look at this side of the equipment. The wiring method is same. The red corresponding to the load side. The corresponding red, black corresponds to black. Then in the middle is the voltage acquisition line. Then this is 220 V, power cord for supplying power to equipment. The equipment wiring finished. We move to device front, then turn on the machine. After turning on the machine, we have a setting here. Password 13982. Enter the system settings. Parallel working mode in settings. When opened, it means parallel working. It is turned off now. We use just one main host now. This is the number of parallel machines. For example, you have two machines. One is a master, one is a slave machine. Let's set one here. It indicates that there is one slave machine. Here indicates frequency band of wireless module you bought. There are only 4 channels from 1 to 4. Below is remote control switch. Remote control. For example, if you control it with the upper computer, you need to turn it on. This is a switch between Chinese and English. The main points to note are these two modes. Parallel mode. If you only have one device, don't need to care it. You can set as a slave machine or a master machine. By default, if only one device is working, this one device considered as master by default. Then the remote control mode. If use upper machine to control the discharge of current. If operating on a computer, then the remote control can be turned on. Then the upper computer is turned on. Connect to this device, OK. Test setting, click on the parameter interface. The working voltage range and current range can be seen. Then click on the test interface. Then click modify. Here are some basic parameters of our discharge settings. For example, the voltage of our battery pack. It is available from 12 volts to 600 volts. Communication method of module. On and off functions of cell module. If there is cell monitoring, turn it on. This is maximum current. For example, this device is 300 amperes. Let's set 310 or 305, 5 to 10 amperes higher. This is an overcurrent prevention setting. This is the number of cell failures. The module monitors the number of faults in battery. For example, set 2. When it monitors there are 2 faults, it will give an alarm. Here are the positive start and negative start of battery pack. By default, we start with a negative start. It is generally connected from the negative terminal to positive terminal. The following is the recording interval of data, from 1 minute to 1 hour. Here is the type of cell module. 1.2 volts, 2 volts, 12 volts, 4 volts. Here is the choosing of sensor. We choose internal. Capacity setting. The value can be set based on capacity of battery pack on site. This is the number of monitoring modules. For example, if you have 9 modules, select 9. Then the number of monitored battery cells is 108. After these basic parameters are set, then click OK. Enter the interface for discharge settings. This time based on 110V and 220V 300A, and we have customized with 48 volts for customer. 48V is here too. This is 24, 36, 48. Just choose within the category of battery group. If it's 48 volts, just set here as either 60 or 55. Let's power it up now. Then start the test. After connecting the load battery pack, let's take a look at this voltage. It must be within our working voltage range. Only then can we close the air switch. If it is not within this voltage range, it will display voltage polarity faults. It will alarm, and in this case do not close the air switch. If the voltage exceeds the limit, while closing the circuit breaker burn out the device, burn this instrument, there will be this risk. How to know if the voltage exceeds the limit? Here in the settings, you can see this parameter. It has a voltage range here. Just don't set it beyond this. The maximum should not exceed 264. That's to say, the voltage of battery pack you are going to test should not exceed the limit. After we set it up, after the voltage collection stabilizes, close the air switch. After closing the air switch, click Test. During the test, the current should be between 0 and 300. Then during the test, pay attention to the current value. After it stabilizes, we start to add the next gear. Then the current rises slowly. After stabilization, increase it to 80A. After stabilization, increase it to 100A. After stabilization, increase it to 130A. After stabilization, increase it to 160A. After stabilization, increase it to 180A. After stabilization, increase it to 200A. After stabilization, increase it to 220A. Increase to 240A after stabilization. After stabilization, increase it to 250A. After stabilization, increase to 260A. After stabilization, increase it to 270. After stabilization, increase it to 280A. After stabilization, increase it to 290A. After stabilization, increase it to 295A. Heat dissipation is taking place here. Here is not very hot. The power is too high, more than 60 kilowatts of heat. It will be rather hot here. So when you are using the battery discharge tester for discharge, be sure to keep the air circulating. Ensure heat dissipation. Avoid overheating faults of the machine. Okay, our current test is close to the upper limit of the instrument current. If adjusted to over 300A, as soon as it is overloaded, it will report overcurrent fault. The largest is 300. Let's talk about the functions of these two keys. I'll stop the machine first. It's fine now that it's not so hot here. This button is a control switch. The 220V input power supply passes through this control switch. Then output 48 volts to power the screen. This is the alarm. For example, let's set a capacity. After the capacity is completed, it will alarm. Or rather, we not close the air switch, just click confirm directly. It will also report malfunctions. Just after you click Start, it will report a circuit breaker failure. After reporting malfunction, the buzzer will also ring. It reminds you instrument has a malfunction now. After the capacity or discharge time is completed, it will also prompt that the discharge capacity has been completed or the discharge time is completed. After completion, it will alert you through this alarm. Give a demonstration. Set 0.1 H. The capacity has already reached 0.1 R. It will report the capacity completion immediately. Then an alarm will be triggered. It is now reporting that the capacity is complete. the set actual discharge capacity. After completion, it will give an alarm. After the alarm, then the buzzer will remind you the test is done. Or the discharged capacity has been completed, then prompt you to come and turn it off. It is an alarm function. It monitors the actual capacity or time through our motherboard. Or a cell low voltage limit is too low, it will report a malfunction. When the discharge voltage is lower than the low limit you set, it will also report malfunctions. It is a protective function with a reminder function. This is a USB port. After plugging in USB cable to computer, you can read the data recorded by the motherboard, generate reports. You can also insert the USB flash drive here. The data is read onto a USB flash drive. Save it on a USB flash drive. These are the data that have been measured. Then some basic parameters you set. It's all on this. After you export it, then import it to the computer software. Then it will generate a report. These are the functions of cell module monitoring. Let's save the test data of machine now. Exporting with a USB flash drive can only be done one by one. Multiple selections are available on the computer. For USB flash drives, they can only be exported one by one. The basic operation is finished. Let's turn it off. Let's remove wires first. We'll remove the load wires first, and then the machine wires. After the operation is completed, when it's time to close, the first step is to cut off the circuit breaker. Remove all the wires, meanwhile waiting for measurement data to be saved, then turn power off. Thank you for watching the tutorial video prepared by HD Hipot Tester.